I've been asked to present on how to provide security and privacy in your health information exchange. Slides. What I have is a set of slides that really are going to go very deep, but I'm going to kind of keep it a little bit higher. The slides are part of a webinar that IHE has given, and the recordings of me giving the webinar are available, as well as the slides and any other depth certainly I'm willing to go into. Really what I'm going to be covering is this overall, how do we deal with security and privacy from an IHE perspective, and part of that is drilling down into some of these profiles that you've heard a little bit about in this ATNA, XUA, BPPC, and how do they really work together at the end to control access to the data, and then kind of wrapping it back up. Whenever you speak about security and privacy, it's important to recognize that this is very, very, very many layers. And it starts at these international concepts of what is privacy, and it goes to regional, down at the technical level. So I'm not really going to cover all these different layers, but it's important to recognize one of the things that IHE doesn't do is IHE doesn't define what is the policy that's going to be enforced. What we do is we look at these policies as possible policies, and we say, well, how could we enable that kind of policy to be enforced? So one of the things we're constantly doing at the interoperability layer is how do you define interoperability in privacy and security? So IHE isn't securing everything, we're trying to enable interoperable security. So how do I convey who I am so that you can make a decision that yes, he's worthy of receiving this information? There's an interoperability problem there. How do I say who I am? How do you say, yes, it's okay, and such? So that's the kind of space that IHE works in from a profiling perspective. You have to apply layers on top of that to say, okay, well, this is our policy. And that's where you get into things like Charles was talking about with the projectathon, is it has declared a set of policies and set up a set of rules. Okay, we now use those interoperability specifications from IHE, and we apply our local rules to enforce that policy. So it's multiple layers, and it also needs that same thing that Charles showed between the difference between testing interoperability and implementing. Security and privacy are risk domains. Many of you are doctors, nurses, you understand medical risk, you understand safety risk. These are just risk domains, and it's very important in any risk domain to use risk modeling to identify the most important things to work through. And when you work through a mitigation, to use risk assessment methodologies to make sure that you didn't create a new risk. IHE has a handbook that we use when developing the specifications that is risk-based, so that we consider security and privacy risks while developing. It has to be done when you're building an application, it has to be done again when you're building a network environment, it has to be done again when you're building an exchange. And all of these build upon each other foundationally. This is the high-level map of all of the profiles that IHE has in the privacy and security domain. So each row is one of the profiles that IHE has. Each column is a classic security or privacy concept. And what we have is a checkbox that says, that profile is highly related to this particular aspect. We have a dot to say, well, it's pretty related. The three that are highlighted are really the only three that I'm going to go through, and they're the ones that apply most to a health information exchange, but the others are also available. I'm not going to get into things in depth, but you can encrypt the document. If you really, really need to encrypt the document, you can digitally sign the document. So these are other profiles that we have, but I'm not going to get into too much depth on the amount of time we have. So what I'm now going to move into is this space which is XDS or even XCA, and when we wrote those profiles, they're not security profiles, but when we wrote them, we considered security and privacy, so we built some functionalities into the profile themselves. I'm not going to go deep into these things, but documents, so they're nice big objects, so that scalability-wise you can deal with the document. And those documents can get smaller and smaller as we get better and better technology. Publication is done one patient at a time, so that I know if I publish information, other stuff doesn't leak through here. Queries are done one patient at a time, so that the access control rules are very simple. I don't have to figure out whether, delivering multiple patient information back is going to cause a problem. So we've done some things to simplify. We've built some attributes into the metadata that policies, access control policies can use. Where did the data come from? What kind of data is it? Who was the patient? Who was the author? But we've also built some more classic things in, like the hash code and the size. Again, just kind of giving you a feel for some of the things that we've built right into the specification. So without even, applying a security layer, there's very important parts. This is a really more complex concept in the same space, in that we've also thought through the fact that sometimes you have a document that has some sensitive information in it that only a few people should see, but it's got so much more that more people really should see. The most basic concept that we built into XDS is that there is a concept of a document having a transform. And you could say, here's the full document as I authored it, complete with all that sensitive information. And oh, by the way, I know that the patient doesn't want this to be seen, so I'll publish a transform. And there's metadata that indicates that this is the restricted one, and this is the one that's been made normalized. But both of them are fully attested as documents. They have an author. That author is absolutely indicated, yes, they're the author of this. Now, this isn't used all the time. This is a special case. But it's, again, a concept of something we built into the profile that you can use towards security and privacy. So next, I'm going to get into the most fundamental of the IHE profiles for security, and it's got this funny name, audit trails and node authentication, and it's actually got three particular responsibilities. One of them is just really not exposed because it's not anything to do with interoperability, it's a functionality aspect in ATNA. So the three functionalities that ATNA requires is that when a system declares that it's a secure node, it declares that it protects data that it has, and it will protect data that it receives. So it's a declaration of functionality, it's not interoperability. But because we've declared that, we can then say, okay, good. One of the things of protecting is you'll audit, right? Oh, yes, we'll audit. And we created this audit log mechanism that when an event happens, okay, record who was it, where were they, why did they access the data, what data did they access, whose data was it, and that's an audit log message. Some attributes about that is we try not to include descriptive information. We try to use identifiers wherever possible, Because ultimately, if we ever need to do reporting, that reporting tool will have access to the patient identity demographics, so we don't have to put the demographics into the audit message. We can just put the patient identity in there. We don't have to put the name of the provider in the audit log because they have access to the directory. We don't even have to put the title or the type of document because we can always look up the document. So the audit log is designed to be as minimal exposure as possible, yet completely covering who, what, where, when, why, which is the information you need to know when you're doing either a forensic security investigation or you're doing a privacy accounting of disclosures. So it has the necessary information, but again, it tries to minimize the exposure of that information. And then the other piece of that, which is usually the piece people come at first, is we have this secure communications where a requesting system will contact a service, and both of them will get the opportunity to authenticate the other, so that a service now knows they are talking to a client that they should be talking to and not somebody else. The client is talking to the server. Yep, that was the server I intended to connect to, and of course the communications is secure. Usually this is done with TLS. There are other mechanisms in the profile as well, but the one that covers this through the most efficiently and the easiest to configure is TLS. And that is what we kind of show here, is that there's this concept of taking a system and creating a security boundary around it, making these strong connections between systems so that ultimately you have a secure environment, essentially cutting it off from the non-secure world. And then this is a diagram speaking through the concepts of this audit. When you have many different systems on the edge here who are accessing patient data, each one of those might be creating an audit message. In this case, all of those audit messages are going to a local repository, and because those are there, you can do investigations, you can do reporting. The mechanisms we use for the audit log support delivering these locally, support delivering them centrally, support delivering them to different filtering criteria and such. So there's a lot of functionality there. So that's pretty much what I'm going to cover on ATNA. Clearly, we can go very deep on that, but I kind of want to make sure I get through some of these others as well. So XUA is a user assertion in the cross-community environment, so this X environment. So it's intended to say, wait a minute, when I'm communicating from one organization to another organization, it's great that our machines can talk to each other and be sure that they're talking to only each other. But who is that user sitting behind that machine? Well, XUA provides that ability to say, who is that user? What is their role? Where are they at? What is the purpose? What is their intent on accessing this information? Was it for treatment? Was it for some kind of research, some kind of quality reporting? And the profile makes sure that you can support this idea of federated identities. So each organization can own their own user identities because they're the ones who are most quick to add individuals. They're most quick to recognize when an individual moves from department to department to change roles. And they're the ones who are most quick to be able to stop a user account from being able to be used. So it supports this concept of being able to locally administer these user databases and providing enough information. Again, this idea of providing enough information to enable the access control decision at the relying party at the service side. It, of course, does support the ability to not do it that way, but we wanted to make sure that we supported, again, the broadest set of policies that could be used. This is a deep, a picture of the packet as it goes across, and it's talking about, who is the authority, who issued this particular chunk of data, why was this being sent, who is the user, what are they asking to do. So this user assertion here is intended to say, okay, we've authenticated and strongly communicated, we've been encrypting, now we know who is the user. The next thing that we really need to work through is, well, what is it that the patient has expressed and we agreed to enforce. So now we're looking over here on the service side in the exchange, if you will, to say, well, what has the patient expressed? And BPPC, we started it with basic because we know that this, as it's designed, is really only intended to handle basic kinds of consents, things that are broadly applicable. We are working in the standards to do something beyond basic, but this one is here. It deals with the typical kinds of, yes, I want to share my data. Yes, I want to share it within this region. No, I don't want X to happen. And yes, I will allow break glass overrides. So these kinds of high-level blunt instrument basic has this ability to do. The other thing that we've made sure is capable in here is this is a document, because getting a consent from a patient is really not just a bit that says, yep, we got it, but is really a documentation of this agreement that the patient has said, yes, that's what I want to enforce, and the organization has said, yes, I will enforce that. So there is a legal aspect of this needing to be a document. It has the ability to have a digital signature across it. So if a region has a need to be able to prove that it hasn't changed through a digital signature mechanism, we have a profile for digital signatures. Combine the two and you have a digitally signed consent. We have the ability in this consent for environments that still use pen. So, I've signed a piece of paper and I stick the piece of paper into a scanner. That goes into a PDF to show, yep, that's what I signed. Oh, yeah, that is my signature. And that can be stuffed into this consent document too. So it satisfies a couple of different needs. If you need digital signatures, it can be digitally signed. If you need a scanned image of a wet signature, that can be done. If you, and it also provides that ability to say, what is their consent that they have on file? And because it's a document, when the patient says, no, I want to change my mind, what you do is you create, okay, what's your new decision? I now have a new decision, and I replace the document. So again, we're using the same concepts that XDS has done, provided in the fact that you can have a document, and then you can replace it, and then you can replace it. So in this way, you can say, yep, I opted out yesterday, I opted in today. So the opt-out gets replaced by the opt-in, and now I know, well, the consent that's on file is opt-in. Yeah, but were they opted in yesterday? Well, let me look. Oh yeah, this was replaced on such and such a date. Yep. There's the previous one. Yeah, but back a month before that, no, let's look. Oh, yep, back a month before that, it was, so you have the traceability through that documentation as well. And it's a beautiful ability to take this document concept and be able to use it for multiple things. And in this case, it's an administrative document. It's not, carrying any medical data at all. This diagram is really just kind of showing, pictographically, what we were just discussing. It's really small on the screen. I have to get my glasses on. There we go. So really what it's kind of showing is, on the right side, the doctor is authenticating themselves, identifying themselves, and to the access control system. They're doing this XDS query over into the HIE. It's possible to say, well, okay, we know who you are, we know where you came from. So in the case of step 3, down in the middle, is it can be intercepted. This information can be looked at, and it can say, okay, we need to look at the consents. You look at the consents. Yep, the consents match. The user information is here. That's an authorized system, so I can go ahead and forward the request to the registry. The registry can do its registry query and return the results. So this is kind of showing an in the infrastructure way of intercepting the requests, using the information that's in there from an interoperability perspective, enforcing access control, allowing it through, or quite honestly, no, sorry, you have no access and the registry isn't touched, no data is exposed. I kind of skip over that. So just kind of going through this last couple of ones a little bit faster, is really kind of trying to bring these things together. We've kind of talked a little bit of it already. We do have a white paper out of IHE that talks to this in great depth, and it speaks about all the various attributes of access control. And again, you need to consider all those layers we were talking about, the fact that we have interoperability, the fact that there's policies, and such. This is a diagram. There's no way I'm going to go into it, but you can kind of see this idea that there is different domains of information. There's user information, there's patient information, there's consents, there's organizational rules, there's the actual image or document data, so it's all of these things marching together. One thing I want to come back to is this concept of, accountability. There is two predominant concepts in accountability. One is predominantly access control, which basically says, I will always be, every rule must match, absolutely no questions asked. It's strictly role-based access control. It's strictly every transaction. There's no questions, no issues there. There's another one that you start to see when safety tends to be far more prevalent in that you kind of say, well, we have general concepts of, yes, these are doctors. Yes, these are patients. Yes, this is information. And you can, in this model, you are less reliant on restricting the data from access because you're more reliant on looking at the audit log and saying, okay, our policy is that you're not supposed to be looking at patients in your family, but you did. So there's this concept, and never is one or the other involved. As in any risk domain, you tend to balance these out. Oftentimes, we do stress patient safety in healthcare as, oh yes, we don't kill patients because of privacy. That's not always ever a conflict. Most of the time, you can find rules that recognize patient safety and privacy and security equally. So, although I agree that when push comes to shove, safety tends to be the one that is preferred, there are also times when it's not. So it's important to recognize early on when you're writing those policies, what is it? What are those times when there's a conflict? And let's decide up front what the rule is going to be. Because when you decide up front, you can then say, okay, I want to opt out. I don't want my data to be viewed. Okay, but what happens if you are unconscious and you are unable to override that for us? Do you want us to be able to access the data for treatment? Some will say yes. Some will say no. That means you need two policies. No problem. You have two policies. So what I'm trying to stress here is don't let the thought that safety and treatment is going to always override. Think through those up front and consider what you can do, what you can offer, and make sure that the rules themselves are clear. And that's kind of what I had. I'll leave this up here as we transition. These slides are from a set of webinars that IHE has.